Hello everybody, Cliff here again from 8 Ions. In this video we'll be looking at basic configuration management with Ansible playbooks and salt states. Let's jump right into it. Here I'm doing the phase 1 and phase 2 build and provisioning steps. Okay, now that that first part is done, let's go ahead and push out our keys. Okay, now let's push out our SSH key. Now this piece is just to illustrate that we have clean working hosts. Fabric doesn't really have higher level configuration management features built in. There are some contributed modules that you might want to look at, but for full-blown configuration management, Salt and Ansible are where it's at. Now let's start with the Ansible playbook. Now here in our phase 3 Ansible directory, we have an inventory file with groups. Our playbook is a YAML file. At the top of the file, we have our host definition, which happens to correspond to the group in our inventory file called evens. What this means is that every host that's part of the evens group in our inventory file will be the target for this playbook. Here we have sudo set to yes, meaning that we'll use it to run our tasks. And here we have a bunch of task items, starting off with packages that get installed. Information on the modules and the various options is available in the Ansible documentation. We have a service module, which in this case is going to set up salt minions and an example foo user just for kicks. Here we copy a minion config file, and down here we have another call to the service module, which will start the salt minions. When we were running things in a one-off fashion from the command line, we could use the Ansible command. To run a playbook, we'd use the Ansible playbook command. Here we indicate which inventory file we want to use and the playbook. That's all you need to get going with Ansible. So let's run it and see what we get. Now here we have a problem because we didn't remove the host keys from our old hosts. So let's do that. While we're at it, let's ignore host key verification altogether since we're in an isolated environment. Okay, looks like that completed successfully. Let's take a look at our output. We can see at the beginning it starts gathering facts. Now those facts can be used inside your playbooks. That's a bit beyond the scope of what we're trying to cover here. We also notice that it is running through the tasks on each host, and it's only targeting the even numbered hosts. Notice that most of the packages that we had specified were already installed when we did our provisioning step. Here we get to some packages that weren't installed, and instead of just saying okay, it indicates that there was a change made. For the service, Salt Minion, we had to get that to be enabled, which it wasn't before. We created our foo user, which was another change. We copied out our config file, which again was a change, and we restarted the salt minion. So let's go ahead and run this one more time and see what the output looks like. Okay, this time, if we look at the play recap at the bottom, we see that there was one change for each of the hosts given. And if we scroll back through our output, we can see that all of the tasks are marked as okay, not changed, for each of the hosts, with the exception of the very last one, which is the service call to restart the minion. Restarting a service is considered a change, and ours, if we look at our playbook, says to restart the minion, and that's going to restart it every time that playbook is run. So a good bonus challenge would be to figure out how you make it so that the service only gets restarted when its configuration file changes. So that's a basic look at Ansible playbooks. Now let's dig into salt states. We've got a bit of setup to do here. Previously, we'd used salt SSH for executing commands because it's trivial to get started with, but salt was designed to use a powerful messaging bus. The configuration takes a minute, but it's well worth it. First, let's install salt using the FreeBSD package system. Now let's configure our master to be enabled. To do this, we need to edit the RC file. And add an entry for salt master enable and set it to yes. Lastly, we need to copy the master.sample file to a file called master under user local etc salt. Then we edit the file. And there are just a few things we need to set. First, we need to set the interface to our IP address. In this case, it's going to be 10.100.182.10. We also need to set the user to student 00. Once that's done, write and quit the file. And before we start it, let's take a look at the file that we pushed out to our minions using Ansible. Here you can see that we configured the minions to connect to a master. And we did this by specifying the IP address of the master that we're running. That's all the configuration you need to do. Now let's go ahead and start our master. While we're at it, let's go ahead and put our state files where they'll be expected. In this case, it'll be user local etc salt states. But first we need to make sure that the directory is there. And we need to make sure that it's owned by student 00 since that's the user we're using to run salt. Now we can copy the files out. We can see with the which command that I have two versions of salt installed. The first one is the one that came as part of the pip package and the second came from the FreeBSD package. Now, generally speaking, you don't want to mix versions of Salt. In this case, because of this environment and what we're doing, actually no, it's okay for us to do this, but we need to install the 0MQ module for the version of Salt that's listed first. To do that, we just do pip install pyzmq. Now that that's done, let's go ahead and take a look at our state files. Okay, the first one is our top.sls file. This is what Salt looks for by default, and it's pretty simple. We have an environment called base. We target our files. We target our hosts here. In this case, the asterisk means hit every host that we know of, and the states to apply to the given hosts. In this case, we have a state file called phase 3. Inside phase 3, we have much of what we had in the other file. A few calls to the package module, in this case installing sudo bash zsh and a few others. And we don't really have another service that we need to set up, but we do create a user called fooUser2. Note that while Ansible and Salt use YAML for expressing desired state, their structure is slightly different. In these examples, I've used the formatting that is idiomatic of the example code and the documentation from the respective projects, but formatting is superficial. The structure is what's important. Also, I should mention here that Salt uses YAML by default, but supports many more options. I won't go into great detail here. You should look at the renderer's documentation for more information. There is support for JSON, pure Python, a Python DSL, and several template languages such as Jinja, Mako, and Wimpy. Ansible does have support for Jinja 2 built into their playbook parser, but no options for other template languages or alternative data formats at this time. Before we can apply our state file, we first have to add our minions to our Salt master. We do this with the salt key command. Passing the -L option, we should see all of the minions that are trying to connect to our master. And in this case, we don't, because our Salt master was started after our Salt minions. So first we need to restart our minions. In order to do this, we will just rerun our Ansible playbook, since we know that it restarts the minions as part of its run. It's perfectly safe to do this because it doesn't make any changes that it doesn't need to. Now that that's done and our minions are restarted, we should be able to see some hosts when we issue the salt key command again. So we've got a list of hosts under unaccepted keys, and if I want, I can accept these one by one. If that's too tedious, I can simply use -A, and I will be prompted to accept all of them at once. If I issue the salt key list command again, they should all be accepted now. I can verify that the master is communicating with the minions, and vice versa, by using the test ping command. In order to run our states, we can just issue the state.highstate command. Okay, for some reason I had a problem executing this as the student 00 user, so I just wrapped it in a sudo. We can see that we have success on 11 items and 0 have failed. Okay, and we can see that here we get a breakdown by host of each state that was run and whether it was successful or not. Now it's worth mentioning that you can change the format of the output here. Salt is very flexible that way. You can also have the output, instead of being returned to you directly on the console, you can have it go into another system using the salt returners feature. All right, that's it for our basic look at Salt and Ansible configuration management. There are many things we did not get to cover. Ansible Tower is an enterprise web console for managing hosts and playbooks. There's much more to know about playbooks and state capabilities, like how to use variables and the various template systems. Salt has returners, which handle output from modules so that you can put them in a database or some other application. Pillars and grains for targeting specific hosts or configurations, and reactors. The Ansible deployment and execution model is basically what we demonstrated here. Salt, on the other hand, has a much more complex but flexible architecture. You can use it in an agentless push mode, similarly to the way that we used Ansible. We showed that with the salt SSH command. It also has an agented pull mode and a master push mode. You can use any of those or a combination thereof, and if you add the reactor system into it, you can have an automatically responding self-aware system. At this point, you should have a running environment to play around with. Try making some changes and rerunning the files. Check out the module documentation and try to extend the included state and playbook or create your own.